Hello, welcome to RVB Education. In this video lesson, we are going to find centroid and moment of inertia of given figure. This is a problem statement. The given lamina is single symmetric. It is symmetric about a vertical centroidal axis but not to the horizontal centroidal axis. These formulae are useful while solving this problem. Kindly take note of them. Choosing a reference axis or edge is a crucial step while finding the centroid and moment of inertia of a given section. Once you decide this, you should perform all calculations with respect to that axis. After selecting the reference axis or edge, the given complex shape is divided into simple standard shapes. Here, the section is divided into a rectangle and semicircle. To better understand the concept of centroid calculation, we do calculations of centroid from top edge and from the bottom side also. However, you can use either approach to solve the problem. First, we do centroid calculation from the top edge. First, we do for the rectangle. This is a 75 millimeter from the top edge. Next, we do the calculation for the semicircle by using a standard formula 4r by 35 and we get this answer 21.22 millimeter. Next, show the values in the diagram. Look at here. Now, we do centroidal calculation from the bottom edge. See here, we will solve. Here we got 75 millimeter centroid of the rectangle from the bottom edge. Then we do it for semicircle also. And we get 128.78 millimeter. And we can show this diagrammatically. Let's look at here. Many students get confused while determining the centroid of semicircle from a particular reference axis. Just see here. In this figure, the centroid location of the semicircle is calculated in two different ways to show that both approaches lead to the same result. We know that the centroid of semicircle is located at a distance of 4r by 3 pi from the diameter towards the curved surface. Since the centroid of the semicircle lies below the diameter, in this case, we use directly the standard centroid formula and we get this 21.22 millimeter. Just look at here. While calculating the centroid of semicircle from the bottom edge, we have to know that the centroid is located at 21.22 millimeter below the top edge. So its a distance from the bottom edge becomes 150 minus 21.22 millimeter. We get 128.78 millimeter. If we add this both the values, we get the same height, 150 millimeter. Now proceed to calculate the centroid of section from reference axis from top edge. Here the solution is shown step by step and we get the centroidal distance of given section is at a distance of 94.07 millimeter from the top side. The same result is shown diagrammatically here. To understand concept clearly, learners should also find the centroid of the section from the bottom axis using the same method and check whether the same result is obtained. Next, we calculate the moment of inertia. First, we are going to find moment of inertia about x-axis. The tabular method along with the parallel axis theorem is used to determine the centroid and moment of inertia of given section about an axis when the section is unsymmetric with respect to x-axis. The moment of inertia about x-axis is calculated using the parallel axis theorem and it needs a centroidal data of the section. The calculations are performed by step. Just go through here and we get the final value of moment of inertia about x-axis. Next, the moment of inertia about y-axis is calculated here. We use the direct formula because the given section is symmetric about the vertical axis. After solving all steps, we come this solution. After completing all the calculations, we get these final answers and this completes the problem. Take this problem for practice and drop your answers in the comment box. I hope this video lesson helped you to understand the concept. Subscribe to my channel for more lessons. Thank you.